right, welcome to Unit 4, Part 6, talking about isosceles and equilateral triangles. Remember, an isosceles triangle is one in which two or more sides are congruent. And so, in an isosceles triangle, you have two congruent sides, which are called the legs. The legs are the two congruent sides. The base, that is the non-congruent side. So here you have the legs of the isosceles triangle, and then you have the base. The vertex is the vertex at which the two legs meet. So this would be the vertex of the isosceles triangle because that's where the two legs meet. The vertex angle is the angle at the vertex. So in this case, this would be the vertex angle right here. The base angles are the angles at the base, which are right here and right here. So these are the base angles. All right, so some things about isosceles triangles. If two sides of a triangle are congruent, then the opposite angles are also congruent. So basically, if the triangle is isosceles, we know that the base angles are also congruent. That is the isosceles triangle theorem. There's also the converse, which says that if the base angles are congruent, then the sides opposite the base angles are congruent, which is the converse of the isosceles theorem, triangle theorem. So here it says, name two unmarked congruent triangles and two unmarked congruent angles and two unmarked congruent sides. Well, if these two angles are congruent right here, then you know that the side's opposite. So you know that BD is congruent to BC. And then because these two sides are congruent here, you know that angle BCA is congruent to angle BAC because of the isosceles triangle theorem. All right, so now here it says name all pairs of congruent angles and congruent sides. So because these two angles these two sides are congruent, we can say that angle JMK is congruent to angle JKL. Because of the isosceles triangle theorem. We can also say that because these angles are congruent, that PM is congruent to PK. Because of the isosceles triangle. So that's what we could say because of the isosceles triangle theorem. There's other things that we could eventually prove, but because of the isosceles triangle, those are the two things that happen. An equilateral triangle, if a triangle is equilateral, it is also going to be equiangular, meaning all the angles are congruent. And in fact, if all the angles of the triangle are congruent, that means they're all 60, because remember, it has to add up to 180. So that's what these two theorems say, is that if a triangle is equilateral, if and only if it's equiangular, and if a triangle is equiangular, then the angle measures are 60 degrees. So here it says find the measure of angle P, angle R, and PR. Well, here we have an isosceles triangle, which means that these two angles are congruent. And if this base angle or the vertex angle is 60, that means there's 120 left over, which means that angle P and angle R must also be 60 degrees. And if P and R are 60, not only is it an isosceles triangle, but it's equilateral, which means that PR is equal to 5 centimeters. So 46, notice these two sides are congruent, so that means these two angles are congruent. They're 60 and 60, which means that this is also going to be 60, which means it's equilateral, and it's 3.5. So the measure of angle T and the measure of angle R are both 60 degrees. And ST is equal to 3.5. All right, so let's look at the next picture. It says to find x, y, and then to find the measure of all the angles and sides. So because these two sides are congruent, that means these two angles here are congruent. So if this is 4x minus 8, that is also 4x minus 8. So all three of them are 4x minus 8, which means they have to equal 60 degrees because it's an equilateral triangle. So if we add 8 and divide by 4, you get that x equals 17. And that means that the measure of angle D is 4 times 17 minus 8, which is 60 degrees. And that's the same for measure of angle E and the measure of angle F. As far as y goes, all the sides are congruent because it's equilateral, so we can set two of the sides equal to each other. So 6x plus 3 and 8y minus 5, or 6y minus 3 and 8y minus 5. Subtract 6y, add 5, and then you get y equals 4. And the measure of the sides, well, let's find what FE is. 8 times 4 minus 5. 32 minus 5 is 27. So that means all the sides are 27. So DE is 27. And DF is also 27. Well, here it's telling you, because of the marks, that this is an equilateral triangle, which means that it's also equiangular. And if it says to find the measure of each angle, well, you know it's 60 degrees for each angle. If you want to find x, well, 3x equals 60, x equals 20. And then to find y, you would set 8 equal to 2y minus 6. And that gives you y equals 7. All right, so that concludes our video on part 6. We'll move on to unit 5 next. Have a good evening.